You've likely heard the name Tesla at this point. Maybe you think these are the coolest cars ever to exist, maybe you think they are ridiculous, but one thing many are unaware of is Tesla's manufacturing process. When it comes to manufacturing, Tesla is at the cutting edge, always experimenting with new technologies. Experimentation is one thing, but bringing new manufacturing tech to scale is what truly makes a difference. Electric cars, by their very nature, are more expensive to manufacture, largely due to their battery packs, so Tesla doesn't experiment for experimentation's sake. They get down to core principles on everything to see how their cars can be made for less. This is paid off in a major way, and is the primary driver for Tesla being one of the only companies that actually makes a profit on their EV sales. As a matter of fact, Tesla has been changing the way cars are made since the launch of the original Model S in 2012. One of Tesla's latest innovations, which we'll cover in this video, is one that companies are particularly keen to implement themselves, and that's their large megacasting used for cars like the Model Y. All of this has led Tesla to their current manufacturing capacity, which massively outpaces their competitors when it comes to EVs. In fact, Tesla produces a new car every 13 seconds. Today, we're going to walk through how this is possible and how Tesla could improve this even more in the future. So let's get into it. When looking at a company like Tesla, you may see battery tech or software as their true long-term advantage, but according to CEO Elon Musk back in 2020, quote, Tesla's long-term competitive advantage will be manufacturing. It's great to be able to make a prototype of a car, but scaling that up in a cost-effective manner is what truly makes EVs profitable. Tesla has a lot of innovation there. Quote, the factory system already has more software than the car, and will probably have an order of magnitude more long-term. Tesla's manufacturing website details their 70,000 plus global workforce across 3 continents, but they started out with only one factory in Fremont, California. Today, this is still one of their most productive factories. After purchasing this factory in 2010 from a previous joint venture between GM and Toyota, Tesla rolled the first Model S out of it in 2012. Right from the get-go, Tesla was innovating the manufacturing process. At the time, the Model S was significantly different than any other car being produced at any sort of scale. So Tesla automatically had to bring things in-house. This brings the vertical integration benefit long-term, but they also were somewhat forced into it with certain processes. The original Model S had its battery cells supplied by Panasonic, and then Tesla assembled those into battery packs at their factory. From there comes the manufacturing process that Tesla was working with around 11 years ago, so this has already changed quite a bit. First, Tesla would start with raw materials, cut blanks, and feed those to press lines. Gigantic dies would stamp panels, and they had a rate of 1 panel stamped every 6 seconds. Those parts would then make their way to the body shop, where the underbody and sides are put together using 5 different joining methods, and that full body would then head to the paint shop. There it would go through all pre-treatment, primer, base coats, and paint, all from robots. Then came general assembly. Robots moved these bodies around the factory on magnetic strips, and the car was assembled from the inside out. Robots placed seats, glue on windshields, and more. At the time, Tesla was building a Model S from raw material to completion every 3 to 5 days. So how have we now gotten as low as 13 seconds? In 2017, Tesla shipped the first Model 3. This vehicle was highly anticipated due to its lower cost, and it did end up changing the EV landscape, but not without massive challenge. For the Model 3, Tesla attempted to innovate a lot, but ultimately found it to be too much at the time. Quote, we had this crazy, complex network of conveyor belts, and it was not working, so we got rid of the whole thing. Around this time is where Elon Musk's algorithm became more commonplace at Tesla. This is detailed in Walter Isaacson's biography of Elon Musk, but essentially involves 5 steps. Step 1, question every requirement. Step 2, delete any part or process you can. Step 3, simplify and optimize. Step 4, accelerate cycle time. And 5, automate. This step coming last is ultimately what they learned the hard way at Fremont. Around this time, Tesla partnered with Panasonic to build, quote, the highest volume battery plant in the world. There they started building stationary storage batteries, along with Model 3 batteries and motors. Then came the tents. In 2018, to help with production capacity, Tesla debuted the tent. This is more permanent than an actual tent, but far from a typical factory structure, but it helped Tesla ramp up production on the Model 3, and ultimately led to the unveil of the Model Y. First though, Tesla expanded to their second vehicle factory. At this point, they had Fremont making the Model S, X, and 3, and Nevada making batteries and motors. Overseas though, they built Giga Shanghai. This factory remains one of Tesla's most impressive feats, because they broke ground there on January 7th, 2019, and produced cars quickly. At the groundbreaking ceremony, Elon Musk said, quote, "This will be the most advanced Tesla Gigafactory. With resources here, we are able to build this factory in record time, and we are hoping to have initial production of Tesla Model 3 toward the end of the year and volume production next year." When Elon gives a timeline, we typically add some time to it, but here, Tesla rolled the first Chinese-made Model 3 off the assembly line by November of the same year. They ramped quickly, and today Giga Shanghai holds the title of Tesla's most productive factory, nearing an annual capacity of 1 million cars. In general, Tesla is following the same basic process as Model S production, but doing it with more advanced automation, cloud systems, cost reduction, localized supply, and more. Tesla staff said at the time that, quote, "You can barely see any staff on the production line. Almost all of the steps in the production process are completed using advanced robotics, all connected to one cloud system." Pretty quickly, it was clear Tesla made a ton of improvements in manufacturing when building Giga Shanghai, and they had the advantage of designing that factory from the ground up, instead of taking over an existing one like they did at Fremont. This very much influenced their future factories. Today, the Model Y is Tesla's best-selling vehicle, and ultimately, this car is what has gotten them to their current rate of a new car every 13 seconds. They manufacture this car in two distinct ways today, and as always, Tesla is constantly working to simplify and bring down cost. The first factory to produce the Model Y was Fremont. In March of 2020, the first Model Ys were delivered to customers. In general, this car was fairly similar to the Model 3. From the outside, and even inside, it just looks like a bigger Model 3. But under the surface is where things get really interesting. This is where some big Tesla innovation has brought down cost, improved production capacity, and scared competitors. Over time with the Model Y, Tesla began utilizing the GigaPress. This idea somewhat originated from Elon Musk looking at a toy Model S one day. According to Walter Isaacson's biography of Elon, quote, "It looked like a miniaturized copy of the real car, and when he took it apart, he saw that it even had a suspension inside, but the entire underbody of the car had been die-cast as one piece of metal." At a meeting of his team that day, Musk pulled out the toy and put it on the white conference room table. Quote, "Why can't we do that?" he asked. After pushback, Elon simply said, "Ask for a bigger casting machine. It's not as if that would break the laws of physics." Tesla finally found the company Idra from Italy to partner with and take on this challenge. The goal was that a single cast could churn out the entire rear and front underbodies of the Model Y. Here, quote, "The machines inject bursts of molten aluminum into a cold casting mold, which can spit out in just 80 seconds an entire chassis that used to contain more than 100 parts that had to be welded, riveted, or bonded together." Tesla has specifically outlined simplicity here with very clear graphics. The Model 3 rear underbody used to be 70 pieces. In the Model Y, they have it down to 2 and plan to make it a single piece. Today, they utilize this at all of their factories, but Giga Texas was built specifically with technologies like these in mind. So the entire underbody of the Model Y has essentially been simplified to 3 pieces: front casting, rear casting, and battery pack. This advancement is something that is seen on the Model Y as a whole today, but we've actually seen another iteration of this come with Tesla's 4680 Model Y. That utilizes a structural battery pack and further simplifies assembly. Munro and Associates, automotive manufacturing experts, disassembled this Model Y and demonstrated how the structural battery takes Tesla's simplicity to another level. The seats and interior are connected directly to the top of the battery pack, meaning that general assembly gets that much easier. Advancements like these are huge ways that Tesla saves on cost with their cars, but also speeds up production time to get down to where they are today, producing a car every 13 seconds. But technically, Tesla doesn't actually do this pack strategy on the Model Y anymore. It will likely return when they reintroduce the 4680 cell Model Y, but the Cybertruck is Tesla's latest car with their latest innovations. Before we get to Tesla's latest car though, how do we get down to Tesla producing a car every 13 seconds? Well, it's fairly simple. We're not talking about a crazy fast manufacturing process where Tesla is literally rolling a Model Y from start to finish off of a single assembly line in 13 seconds. What they are doing, though, is producing cars in such high quantities between multiple factories with multiple assembly lines that the average is a new car produced every 13 seconds by Tesla. At Giga Shanghai by itself, actually, Tesla recently raised its production capacity to over 950,000. Thanks to a production process that is now 95% automated, reports are saying that Tesla produces a Model Y out of that factory every 30 seconds. This is for that car alone at one single Tesla factory. So let's look at Tesla's entire production capacity. In California, Tesla makes 4 cars. They produce 100,000 Model S and X vehicles annually, along with over 550,000 Model 3s and Ys. In Shanghai, they can make over 950,000 Model 3s and Ys annually, In Berlin, they can make over 375,000 Model Ys. And lastly, at Giga Texas, Tesla can make over 250,000 Model Ys and can make over 125,000 Cybertrucks a year. Adding all of these numbers up going forward, Tesla is capable of producing 2,350,000 electric vehicles each year. Compared to some other brands, this may not sound all that impressive, but these are exclusively electric vehicles, all requiring large battery packs, so this is an incredible feat. In any case, there are 31,356,000 seconds in a year. Divide that by Tesla's annual current production capacity, and Tesla is producing a car every 13.41 seconds. It's a remarkable feat and something that is only expected to increase in the near future. The other aspect here, though, is that it's one thing to talk about the full package of a car, but those batteries and motors must be made at an incredible pace as well. For batteries, Tesla uses a mix of suppliers and their own batteries, but for motors, they are entirely made in-house. At the end of July, Tesla posted a huge milestone there. They said, quote, "produced our 10 millionth drive unit across all our factories." Elon Musk responded to say, "Congrats to the Tesla drivetrain team." But then Tesla Manufacturing further explained this in seconds. Quote, "Every 5 seconds, we welcome a new drive unit into the world." Their math seems to be taking uptime into account, but this also does make a lot of sense. A new car every 13 seconds, with many of those cars requiring 2 motors that Tesla, when production is rolling on motors, makes every 5 seconds. The Cybertruck Model S and X also have a trim that used 3 motors. Elon further expanded here, saying one day Tesla will make a drivetrain per second. In a future envisioned by Tesla, even without human drivers, motors will always be required, and this would essentially multiply Tesla's current manufacturing rate by 5, producing well over 10 million vehicles each year. That's a lot of cars, so how will Tesla achieve this? Will they simply build 5 times the manufacturing capacity, or will they achieve this with future manufacturing advances? The latter seems to be much more in play here, especially in the immediate future. For the Cybertruck, Tesla designed it from the ground up with manufacturing in mind, and they have implemented some of their most impressive technology on it. First is that structural pack we just talked about with the Model Y. The Cybertruck seats are attached right to the Cybertruck battery pack, simplifying assembly. Then this features the largest castings ever done on a vehicle. The Cybertruck utilizes a 9,000-ton gigapress from Idra. It's a massive machine, but it churns out huge castings that simplify the Cybertruck's production, just like the Model Y did. This is actually Tesla's latest, most advanced vehicle, and Tesla gave everyone a tour of the production line at their event. We can see disassembled Cybertruck pieces on display here, but on the assembly line itself is where we have tons of robots. Here's one demonstrating adhesive application, and another demonstrating vertical lifts. Right here is a robot they've been using for a while now, but a version specifically for the Cybertruck's giant windshield. We can see it flip around, get adhesive applied, and then put the glass onto the Cybertruck. It's incredibly impressive to see, and it's what has, surprisingly to many, made the Cybertruck ramp up production so quickly. An annual production capacity of 125,000 is incredibly impressive for this car, and even if Tesla isn't there today, they are on their way. The Cybertruck was already the best-selling electric truck in America for Q2, but churning out cars that lose money doesn't matter much in the long run. At the end of the day, unless EVs can be scaled profitably, they won't last. For the Cybertruck's competitors, like the F-150 Lightning, they're still losing tons of money. In fact, for each EV Ford sold in Q1 of this year, including their whole lineup of EVs, they lost about $132,000. Rivian for Q2 lost about $32,705 per vehicle delivered. That's actually a huge improvement over previous quarters, but it shows how difficult this project is. Tesla's innovation is a big reason why, even though the Cybertruck is by far the most recent release of all these cars, they may get it profitable first. In Tesla's most recent shareholder deck, they said, Cybertruck production more than tripled sequentially and remains on track to achieve profitability by end of year. Like it or not, Tesla is the best company in the world at making electric vehicles profitable, and other automakers are starting to take note. Back in 2023, Reuters reported that Toyota planned to adopt Tesla's gigacasting technology to improve performance and lower the cost of their future EVs. When it comes to savings like this, it can be hard to quantify, but Reuters says, quote, "For Tesla, the use of a single component in the rear of the Model Y, its best-selling model, allowed it to cut related costs by 40%. 40% is a massive improvement in cost, especially when it comes to the core structure of a vehicle, but this savings comes in multiple forms. From that piece itself, but also the elimination of tons of manufacturing equipment. Step 2 of that Tesla algorithm is to delete any part or process that you can, and with that gigapress, quote, Tesla was able to remove 600 robots from assembly. The Cybertruck is the latest vehicle to utilize this, taking it to the next level beyond the Model Y, and on top of Toyota, we're seeing GM, Hyundai, and Volvo working on this technology. While many automakers are working on adopting this megacasting technology, which multiple suppliers are making machines for at this point, Tesla is never standing still. Remember that vision of a single stamped underbody for a Tesla vehicle? Well, Tesla still wants to get there. Tesla's upcoming small vehicle platform was supposed to be the first time that Tesla would do the entire underbody in a single piece. Quote, the long-term goal was to radically simplify manufacturing and slash costs. This was their goal here, but things have shifted around a bit for that project. Now it seems that going all the way for a single underbody proved too difficult, at least for now. They are sticking with the underbody comprising 3 pieces for now, but the major reason for this retreat has to do with short-term expenditure. Tesla needs to get a more affordable vehicle out next year, and they now plan to do this with a mix of their new and old platform. This will allow them to build this car on existing assembly lines, but by no means will we never see this technology come to be. In fact, Tesla has a lot planned here. So far, we've mainly talked about Tesla improving aspects of what is a fairly standard general assembly process, but soon they plan to revolutionize that process entirely. In March of 2023, Tesla held their Investor Day event. They detailed a lot of things at that event, all of which relate to cost cutting, but the first thing they detailed was their new Groundup Manufacturing process. Traditionally, a vehicle goes through these various steps. This is a process that has been largely unchanged in 100 years, and if there is a problem anywhere along this line, it ties up the whole factory. Tesla's head of vehicle engineering, Lars Moravy, even called this process silly when showing an illustration of how it all works. You take stamped panels, put them together, put them in a framing station, build a body, put the doors on, paint them, take the doors off, assemble the interior through openings in the car, lift the car up, put the battery underneath, put the seats in, seal it with glass, and then reattach the doors. It's a very complex process, but as of right now, it's the best we can get. Tesla has made improvements like we've talked about throughout this video, but their unboxing process will allow more people or robots to work on the car at the same time by splitting each process up. This allows for better operator density and improves, quote, space-time efficiency. Without entering in and out of the car, it's far easier to automate. In practice, this will lead to parallel and serial assembly with a much smaller final assembly line. Tesla will assemble the parts of the car entirely on their own. Here we can see the full interior being assembled, the doors complete, the front and rear castings complete with drive units and more. They paint what needs to be painted early on, and it's far easier for many different robots to work on this car simultaneously. Quote, we aren't moving heavy objects around and doing nothing to it, and it means we're doing more work on the car more of the time. Then they take all of these sub-assemblies and do one single assembly. The battery with seats comes in from below or above, the sides attach complete, and then the car is closed off one single time with the doors. Here they accurately demonstrate this on a Model Y, but they are very clear that this is a process that will not be for this car. This is for illustration, but it's a process that will come to their next-gen vehicle whenever that comes. This process looks good on the surface, but how does it actually save Tesla? First, it saves in time, because these cars can be assembled even faster, but it reduces their manufacturing footprint by 40% or more. Then when it comes to cost, they expect a 50% reduction. The thing with a revolutionary process like this, though, is that it requires a lot of investment up front. Lots of trial and error. Originally, Tesla's plan here was to build Giga Mexico from the ground up to build this car. That factory would have been designed to manufacture this car specifically, and then Tesla would copy and paste that factory, once optimized, to their other factories around the globe. Fill out Giga Texas, Shanghai, and Berlin with this new assembly line or unboxed parallel assembly process. That was the plan, and Tesla's next-gen vehicle was talked about for quite some time, but things have changed on this front. Tesla changed plans to first build this at Giga Texas. This would optimize their vertical integration process, allowing engineers to work directly on the assembly line in real time as it gets going. On their Q4 2023 earnings report, they said, "We continue to make progress on our next generation platform, but things changed for Q1 of 2024. On that report, Tesla said, "We have updated our future vehicle lineup to accelerate the launch of new models ahead of our previously communicated start of production in the second half of 2025. These new vehicles, including more affordable models, will utilize aspects of the next generation platform, as well as aspects of our current platforms, and will be able to be produced on the same manufacturing lines as our current vehicle lineup. This update may result in achieving less cost reduction than previously expected, but enables us to prudently grow our vehicle volumes in a more capex efficient manner during uncertain times. This would help us fully utilize our current expected maximum capacity of close to 3 million vehicles, enabling more than 50% growth over 2023 production before investing in new manufacturing lines. Our purpose-built robotaxi product will continue to pursue a revolutionary unboxed manufacturing strategy. Right there was a big shift for Tesla. It seems that whatever this next Tesla will be in early 2025, it will utilize some aspects of their next generation platform, but won't quite bring the massive changes we were expecting. In part, this comes because the overall focus seems to be their FSD and robotaxi project. If they can achieve that though, that unboxed strategy will prove even more valuable, since these cars would in theory be autonomous taxis with a ton of demand. All of this to say, it could be some time before we see Tesla truly implement their unboxed strategy. In fact, it could even come alongside a single-piece casting underbody. We just assume that it won't happen next year. That doesn't mean it isn't coming, though. Things like this do move very slowly, and taking huge risks like this take time. After all, the Cybertruck did come to market, but it came to market a full 4 years after it was unveiled. With that said, the unboxed process isn't the only thing we'll see from Tesla in the future to bring down cost and speed things up. At that investor day, they detailed how the powertrain for the Model 3 sees continuous improvement, and how their next powertrain will be even more scalable. They are planning for a 75% reduction in silicon carbide, compatibility with any battery chemistry, a 50% reduction in factory footprint, and $1,000 reduction in all-in cost. Another big piece there is that their next generation permanent magnet motors will eliminate rare earth materials entirely. When it comes to electronics, electronic controllers and general wiring add up in EVs, and Tesla plans for their next generation vehicle to have 100% Tesla-designed controllers. The big one, though, is Tesla's future shift to 48-volt architectures. This is an advancement that they already ship on the Cybertruck, and it's a big deal for a number of reasons. Cars have operated with 12-volt architectures for a very long time at this point. Quote, in traditional 12-volt systems, wiring and components have to be larger and heavier to withstand the high electrical loads. As EVs are requiring more and more here, it keeps adding weight. Quote, a 48-volt system can accommodate high loads more efficiently, which reduces the size and weight of wiring, especially for low-draw componentry. This translates to better vehicle efficiency, better handling, and production efficiency. Some have even gone as far as to call this an industry game changer. It's one that only Tesla could really make at this point, since it requires innovation for every piece of the vehicle. And they started with the Cybertruck, which at this point is an expensive niche vehicle. After working everything out with the 48-volt architecture there, and bringing down costs through scale, they can then bring it to their upcoming, cheaper vehicles. Another evolution for the Cybertruck that should be perfect for their future unboxed car is the Ethernet controller. Wiring harnesses are a huge mess when you truly look at the core of a vehicle. Quote, typically, every sensor and electrical component on a vehicle must be connected to the central controller and the low voltage system for power. Sometimes this means many wires for complex parts. Let's take the door as an example. It might comprise sensors to signal the car's computer whether it is open, closed, or at an angle. This is also true for the windows, which feature buttons to trigger opening and closing. The switches are connected to the vehicle's controller, which in turn is connected to the window actuators to lower or raise the glass. Add the speakers into the equation, and you understand why wiring harnesses are such a mess. Wires spread for miles inside a modern vehicle, adding complexity, costs, and weight. Worse than that, building and installing them is done by hand. With Ethernet, Tesla has been able to eliminate tons of wiring. Quote, for Cybertruck design, we have moved to a local controller where the wire is connected to the nearest controller, and those controllers are connected over Ethernet. Wires are routed to the nearest controller, where the data is converted into a network packet for transmission to the correct location in the car. They specifically say they've eliminated most cross-vehicle wires in the Cybertruck, and then for the next-gen car, they will eliminate all of them thanks to this technology. You might think that there's nothing more that Tesla could do here, but there actually is. Back in 2020, Tesla detailed plans for their future battery technology made in-house, the 4680 cell. Today, this is the battery cell shipping on the Cybertruck. They make it themselves, but recently they had a breakthrough which could further speed up production. At the end of the day, the lower Tesla can bring down cost on their cars, the faster they will be selling them, and that's where the dry cathode comes into play. Recently, Tesla posted through their Cybertruck page on X saying, quote, first prototype Cybertruck with in-house dry cathode 4680 cells, making it an all-dry cathode vehicle. When asked what the advantage of this is, they went on to say cost reduction, also a much more environmentally friendly manufacturing process that will enable us to scale production much quicker. Elon Musk expanded further, saying it's a major breakthrough. The dry cathode process is something Tesla acquired when they acquired Maxwell Technologies, but proving it out has proved difficult. The wet cathodes process is one of the most costly processes in current battery manufacturing, and this new process, once scaled, allows Tesla to make these with a 10x reduction of factory space and 10x reduction in energy. This side by side is their original 4680 presentation and shows how much this simplifies the process. Sawyer Merritt further detailed the advantages here on X, saying that this will help Tesla reduce costs by 15 to 30% on batteries. This allows for smaller, more efficient factories, could lead to higher density batteries, which means more range from the same size pack, and it's better for the environment. He finished by saying, "Last thing I'll note is that various battery companies have been working on the dry method for a while, but all of them have only achieved it at lab or pilot scale at best. So it may seem like Tesla is at that point, but on Tesla's recent earnings call, they said, "We've built our first validation Cybertruck with dry cathode process made on our mass production equipment, which is a huge technical milestone, and we're super proud of that." So yes, one validation truck for now, but it wasn't made in isolation. It was made on the equipment that will allow this to be scaled for Tesla. They also added that they plan for a production launch with the dry cathode in Q4 of this year, 2024, which brings the cost significantly below alternatives. This is the breakthrough that Tesla talked about 4 years ago at Battery Day, so it is a very big deal. It is what will help them make their own in-house batteries cost less than those coming from suppliers, and it's what, once scaled, will further drive down their EV cost. In turn, we could see this be a large piece of what helps them ship their more affordable EVs in 2025, and then the robotaxi, the one with that unboxed process. So this is how Tesla today is producing a new vehicle every 13 seconds. With their current technology and advancements at multiple factories, they've figured out how to produce EVs at scale and make them profitable. They've done this by automating many parts of the manufacturing process, simplifying parts through technologies like the gigacasting, and continuously iterating on every piece of their vehicles thanks to vertical integration across the company. But they aren't stopping anytime soon. Coming up, we're going to see Tesla introducing new technologies like 48-volt architectures, Ethernet controllers, dry cathode batteries, and much more to their consumer vehicles. Some of these will also be assembled using their unboxed manufacturing process that could forever change how vehicles are made. The question now is, will this come to consumer vehicles that we drive? Or will Tesla actually solve self-driving and go all in on their autonomous robotaxi? Only time will tell. In the meantime, if you want to see the latest news coming from Tesla, you can check out that video linked up here or in the description below. Thanks so much for watching, and I'll see you on the next one.